morning, one and all. Today we discuss about the topic instrumentation system. Under this topic, first we discuss about transducer. You all well know about a transducer. Transducer is a device that converts energy from one form to another form. That is called a transducer. If we go for an electrical transducer means that convert any form of energy into electrical form. That is called an electrical transducer. For example, if we take a speaker, that is also a transducer, but it convert that electrical signal into sound energy in speaker. But if we take a microphone, that is transducer. Why? Because that convert sound energy into electric. So that physical quantity is converted into electrical quantity. So that is called a electrical transducer. So whenever the device that convert any physical quantity into electrical quantity, that is called an transducer. Between transducer and sensor. The transducer is nothing but we already discussed that the device that convert energy from one form to another form is called a transducer. But the sensor that can sense or detect the changes in the environment and transfer that information to the another devices, that is called a sensor. This is the major difference between transducer and sensor. This is a difference. And next we go for a construction and working principle of transducer. In a simple transducer that convert the energy from one form to another form. If we go for an electrical transducer that convert the any form of energy into electrical signal, that is called electrical transducer. And inside that transducer there is a sensor and a signal conditioning unit. The sensor convert any form of energy into a same form of energy. That is a sense. It can sense from the device, that is the sensor, and then through the signal conditioning unit, that signal can be converted into a electrical signal. Now, any form of signal is converted into electrical signal, hence it is called electrical transducer. Next, we go for classification of transducer. Initially, the classification based on energy requirement. Common types based on energy requirement. The first one is the active transducer and next passive transducer. The active transducer that can generate a own electrical signal that cannot depend on the external source. That is the active transducer. The example is thermocouple and photovoltaic cell. The next one is the passive transducer. It can need the external power source. It depends on the external power source. Example, that's thermometer or LVDT. These are the example of passive transducer. The next one is the second classification is based on the input quantity. That is the temperature transducer, example thermistor and RTT. And the next one is the displacement transducer, example LVDT and potentiometer. And third is a pressure transducer, example strain gauge, piezoelectric transducer. And then fourth one is transducer, example of this is photodiode and photocells. These are the common types based on the input quantity. Then the third one is the classification of transducer based on the working principle. The first one is the resistive, example potentiometer and strain gauge. It depends on the resistive. The next one is inductive transducer. That is the example is LVDT. And then third is a capacitive transducer, example pressure sensor. And then fourth one is a transducer, example microphone and vibration sensor. And then last one is the photoelectric transducer, example solar cells and LDO. So these are all the types based on the working or principle of operation. These are the classification of transducer. The next we go for thermistor. The first transducer we discussed about the thermistor. The thermistor is nothing but a temperature sensitive device. It can use to measure the temperature And that thermistor is one kind of resistor whose resistivity is depend upon the temperature. Okay, it can measure the temperature, but the temperature depends on surrounding temperature or environmental temperature. That is a thermistor. First, we go for a construction of thermistor. A thermistor is a temperature sensitive device that is made up of a semiconductor material such as manganese, nickel, cobalt, or copper oxides. These are the semiconductor materials used in thermistor. Initially, this material compressed. It will be compressed and it can be made into a different shapes like disc or beads or rod. Okay, these are the common type of shapes used in thermistor. Okay, so that is nothing but the semiconductor material. Okay, that is compressed like this. The material can be compressed and it will be coated, and then from this material there are two leads are taken outside for electrical connection. That is a leads, two leads are there for electrical connections, and then finally this can be coated, okay, glass coated. It will protect from external uh, stresses or external any mechanical or pressure, any external stress that will be protected by using this glass coating. So this is the thing, and these are the different shapes of thermistor. This is about the construction of thermistor. Next we go for an working principle. In that working principle, it is a simple principle that the temperature, the measurement of temperature that will change in resistance. Okay, so the resistance due to the changes in temperature. Now we see what is the relationship between that resistance and temperature. Okay, so here that RT is equal to R naught e power beta 1 by T minus 1 by T naught. RT is nothing but a resistance at temperature T, and then R naught is nothing but a resistance at reference temperature T naught, and the beta is nothing constant. Okay, so here in this working principle, the resistance value will be changed depend upon the surrounding temperature. If the temperature varies, the resistance also varied. Finally, this resistance can be measured by using a simple bridge circuits. Okay, so here in the previous one we see about the two leads or there now. So these two leads will be connected to a simple bridge circuit to measure the resistance value. So that resistance is directly proportional to the temperature value of thermistor. And then the types of thermistor, that will depend on two type. The first one is a negative temperature coefficient thermistor, and the second one is a positive temperature coefficient thermistor. In that negative temperature coefficient thermistor, the resistance is inversely proportional to temperature. Whenever the resistance decreases, the temperature will increase. This is a negative temperature coefficient thermistor. And for positive temperature coefficient thermistor, here the resistance is directly proportional to temperature. Whenever the resistance, the temperature also increased in positive temperature coefficient thermistor. This is the common types of thermistors. And the next we go for an advantage of thermistor. Here it is less expensive and compared to other transducers and more sensitive than other sensors. Okay, it can be used to measure low resistance values, and then low resistance depends on the temperature, and then fast response and the compact in size. These are all the advantage of thermistor. And next we go for a disadvantage of thermistors. It is a limited temperature range. Okay, and then resistance to temperature ratio correlation is not linear, and then an inaccurate measurement may be occur due to the self-heating. Okay, so here it is a small device compact in size, so it will be the temperature. The temperature can affect this construction. So this is some disadvantage of thermistor. And next we go for applications. The thermistor is mainly used in battery pack temperature monitoring and overcurrent protection, inrush current protection, and digital thermostats. These are all the application of thermistors. So till we discuss about that thermistor construction and working principle and its advantage, disadvantage, and applications. The next we move to thermocouple. The thermocouple is a transducer that is used to measure the temperature. It converts temperature into electrical current or voltage that is proportional to a temperature value. So this is a transducer, that is an electrical transducer that can convert a temperature into an electrical current, electrical signal. So it is a electrical transducer, thermocouple. And then now we go now we see about construction of thermocouple. This is a construction. A thermocouple consists of two dissimilar metal wires, for example copper constant or iron constant or chromal aluminum. So these are always some combination of metals, two dissimilar metals. So these are some combinations are given here, for example. And then this is a construction diagram. So here there are two metals, metal A and metal B. Like two dissimilar materials or taken metals are taken here. And then one end of the metal can be joined, okay, coupled here, one end of the metal, and that another end is connected with a cold junction, and this is connected with the measuring system. It is connected with the measuring system, and then the joint place that is kept on a junction. This is a hot junction and this is a cold junction. The two dissimilar metals are joined in hot junction, and then it will be and it is directly connected with the measuring system, and that whole system will be together inside a protective sheath that is used to protect the system from the outer environmental condition or physical stress, outside stress. So that is protected by using the protective sheath. So this is the thing. So here the two metal, it may be a copper constant or iron constant, and so these are all the different metal combinations over there. And mainly, if we go for an working principle, it is mainly works under that Seebeck effect. Okay. So this is a main working principle of thermocouple, Seebeck effect. That is nothing but it states that when or joined at two junctions and the junctions are maintained at temperature, then an EMF generated in the junction. For example, okay, this construction diagram, it can be clearly shows that so joint here. So definitely the temperature can be varied depend on not similar for both the metal, it will be different. So when two dissimilar metals are joined here at two different temperature coefficient. So at that time, what happens? An EMF induced in this place. EMF induced in this place, that is measured through the measuring system. Okay, so that is the thing is given here. Okay, so here according to the temperature, what happened? That EMF will be induced here, generated here. So the formula for an electromotive force generated. Okay, so in this thermocouple is called E, that is equal to alpha into T1 minus T2. Here E is nothing but thermoelectric EMF, and then alpha is a Seebeck coefficient, and T1 is a temperature of hot junction, and T2 is a temperature of cold junction. The working principle. Next, we go for an advantage of thermocouple. So the thermocouple is very cheaper, okay, when compared to other temperature measuring devices. And then the thermocouple has response time and it has a wide temperature range. And then the disadvantage of thermocouple is the thermocouple has low accuracy and recalibration of the thermocouple is difficult. And then we go for applications. Here used for temperature measurement in furnaces, engines and industrial processes. And then it is also used for wide temperature range measurement from minus 200 degrees centigrade to 1800 degrees centigrade. These are all the advantages, disadvantages and applications of thermocouples. So this is the explanation about thermocouple. The next we go for a difference. Okay, so the comparison of thermistor and thermocouple. So here the major difference are given in this table. So here the first one we see about that the what are the materials. Okay, so here the thermistor means it is made up of semiconductor materials. The example of oxides of magnets, nickel, cobalt, etc. And then for thermocouple, it is made up of two dissimilar metals. Example, copper, copper with constant or iron with constant is nothing but a alloy. The second one is based on that it works on change of resistance with temperature thermistor, but thermocouple it depends on the Seebeck effect. The working principle is Seebeck effect. And third one is the output is change in resistance. The thermistor output is resistance, change in resistance. The thermocouple output is millivolt. Why? Because it generates a EMF due to the effect. That is using this we can able to find out that temperature value. Say output is EMF voltage. Then that fourth one is suitable for narrow temperature range, low range, minus 50 degrees centigrade to 150 degrees centigrade. But it is a wide range application. So for example, it minus 200 degrees centigrade to 1800 degrees centigrade. And then the fifth one is it provide high accuracy and sensitive over small ranges. And then for thermocouple provides a less accuracy but suitable for very high temperatures. Sixth one for still it needed external excitation sources. Okay, so it needed external power to operate it. But for thermocouple, it is a self-generating sensor, so there is no need of external power to operate. So this is the thing. And then seventh one is in thermistor, the response time is slower, very low response, but thermocouple faster when compared to the thermistor. And then the last point will come for that commonly used in medical line and HVAC and electronic applications. And for thermocouple, the application is used in industrial furnaces, engines, and power plants. These are all the common difference between thermistor and thermocouples. Thank you.